Hi guys, good evening. So this is our second part two of our SIP by essential system design concepts, which is very important. Whether you're a vibe coder, you're a developer, upcoming developer, whatever you are, you're a business owner, you're trying to scale application, you're trying to build one. Because I think every average person now has an application already, or you're a startup founder, whatever. You need to understand most of these concepts. So if you not watch my first video, you can go back. I will link it below, so you can watch it and understand. So now we have let's go forward. So we have reliability. Is your system reliable? Reliable system means it's work correctly and consistently over time. Like it does what it should. I have a system that does what it should. Availability doesn't mean reliable. Your system might be available and there are some things that won't just work. Probably the user is trying to log in and is not logging in, and the user is trying to upload a profile, is not working. The user is trying to make payment or request payment, is not just working. So availability is different from reliability, which means reliability does what it should do. Availability means your server is up, your system is available for the end user. So now we are going to let's use this as an example. We have available a reliable system simply means it returns correct results. So if a user is trying to get a result from your server, just like I said earlier, it's trying to upload a profile, it does upload. It's trying to request a payment, the payment goes through. It tries to make a payment, the payment also goes through. It tries to do whatever anything it wants to do. The system is reliable, it works. So does not lose data. So your system does not lose data. Probably you have a system that's working and all of a sudden the user can't find his profile anymore. Probably something happened. So this is not reliable. Recovers from failure. Your system must be find a way to recoup and recover from failure. If it goes down today, is if some certain part of the system are not working today, by in the next few minutes they're already working. This is recovering from failures. So now we have an example of um reliability here. Let's say this guy here tries to request a payment from you and he sent his request. Then he tries to send it again, while he's having a balance of just let's say $10. Oh boy, spelling my doing super $10. Now, if there is no way you handle this mechanism, this user is using trying to use $10 to withdraw, is trying to withdraw $10 more more than he can. That means probably trying to withdraw $30 when he has only $10. So now we can use this in the in them potency keys. Sorry for the pronunciation, yeah. Can use this equivalent to identify okay, this guy, this user ID and tag him with a user ID and a token and send it to the server. So it's already been labeled already. Like okay, you've requested money and your balance is only $10 only. So it can't request again. So the network it goes to the server and the server already checks his data and say okay, you already have it goes to the back end, you have a logic in the back end. You already have $10, you only have $10. When it tries to request again, say, well, no, not enough, insufficient fund. Or you use a time block, which means the user doesn't spam you. I mean, they continue clicking. Immediately the user click withdraw, you lock the withdraw button. You just lock it. The withdraw button, you just lock it up. So the user can't actually spam you. Immediately on the first click, you lock it. So those are some kind of a coping mechanism you can use to actually avoid being dragged and have your system being reliable. So we have fault tolerance. Fault tolerance simply says your system continues working even when components fail. So there are some times whereby some part of your system must fail. This is inevitable, no matter how structured your organization is. Some parts must fail. Probably a server crashes, a database outage, or network failure. So if you have a server crashes, you can use an example of replication. Replication simply is an example whereby you're having two servers up, three servers up. You are just redirecting users to the other servers when one server is down. So I had the same issue a while ago when I was building my bot. So the server was down. I couldn't access the bot. So I haven't launched yet. So I was not having this thought like, okay, what if I already have like 10K users already, and which as a fintech bot, it needs to be up 24/7 because one slight mistake, your user lose money, which is bad, very very bad. Your user loses money one slight mistake. So you have network database outrage, which means you can use redundancy to actually um, duplicate your database to have like a different database that's running already. So if this database outrage, you can just point it to the other database. Network failure, you just use them retry mechanisms. So these are very very important. So this is how the hierarchy goes. Primary database fails, and replicate database becomes the primary. The user does not notice anything. This is the good part I'm talking about. Is none of the end user's problem. It's your problem. So you have consistency. Consistency simply means are all the users getting the same data, which is very very important. Because user A might request the same thing from you, while user B might request the same thing, or let's say plus and minus here, while user is trying to like let me just go through the example. So updates must be very very fast. Like how does your system update? So let's say strong consistency, which are basically used in the banks. Let's say use all users see the same data at the same time. If a user withdraw 200 naira today, this user is trying to withdraw 200 naira. The 200 naira must remove from his account immediately, because if you withdraw 200 naira and your system is kind of inconsistent with what he has done, he can still try to withdraw it again. So this is very important. So like all these things like fintech application require strong consistency. So now we are going to the next aspect, which is eventual consistency. The data becomes consistent after some time. So for social medias on any other application that doesn't require financial whatever, you don't need strong consistency. So if user A request for a page, it might probably take a while for it to load and user B, or if it does post a comment, it might probably take a while for the comment to drop and user C your comment drops, or just feeds might probably be different. So you don't need to strong consistency for those ones. But anything financial related, you need strong consistency, which is very very important. I see most SaaS application getting squashed out of these levels because of their consistencies are bad, and they end up losing a lot of money because they don't understand the concept of system designs. So latency is in how long a request can take to complete. So if user request whatever is trying to request something, if your latency is very very slow, let's say you are communicating with an API and the latency is slow, it should take time for you to get that data back. Let's say the API is here, you are requesting for something, it should take time for you to get that data back. This is the user here requesting for something, and it take time for you to get the data back. Let's say user B is requesting for something from another from a faster API, yeah, you being the owner of the API. So user B latency is very fast than your own latency. That means user B gets his data first before your user gets his data. Which for example, a sniping bot now will have more edge if latency is faster. You understand what I'm saying? So these are some of the most important things you are in the fintech space, and you have competition. Some people will tell you we process payment under 0.2 blah blah seconds. That's latency. How fast will it take for a request to complete? So we are looking at under milliseconds, 20 milliseconds, 200 milliseconds, noticeable delay. 2 seconds slow. 2 seconds is too slow for latency for an application. So mostly we are seeing on the public testnet, public RPC, you will have 50 milliseconds to 400 milliseconds. On public RPC on blocks, most blockchains you have, so you will see some blockchain will tell you we are the fastest with blah 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 latency. So these are ways for you to actually improve your latency if you are not running most of these blockchain networks. So you have caching, which is you can use Redis instead of for the servers to keep bombarding, you have a request from the API for the servers to keep bombarding requests to directly to the database. You can just use sketching to actually get the data back faster. So it already has some basic information about these users, and you can just retrieve some necessary thing instead of sending fresh requests every time. So we have this C and CDNS. So this just means you are trying to get streams, data streams faster. Like you can use Cloudflare. So this most of these things are like regional based data center are being pushed. Your service they are being pushed to regional based data centers. So the streams comes fast. So if something is closer to you, you get it faster. Optimize database. You can use edge servers. So servers is an edge. So this throughput here simply measures how many requests a system can handle per second. So if your system is kind of very, very weak, I'm saying so too much requests per second will probably slow down your system. So this goes for most services or that offering all these APIs, allowing others many applications to work with them. Like say allowing other mini applications to work with them. So if this choose this if this mini application have roughly we're talking about 10K users, this one have 300K users, 300K users. So your throughput needs to increase as time goes on because if they keep requesting at the same time, can your can your web application whatever handle those requests, which is very important question for you to ask. If they can't do this, you start upgrading your optimizing your system for them to handle it. So I think most of these things are just you have exchanges, network, messaging platform. Those are the ones with high throughput. So these are just the basic coverage of how system design concept are. So you have the end users, you have the traffic control, which is load balancer, which sends load to different servers on the network. Then you have the application service, whatever application service you can use your data storage. You have your monitoring and scaling. So for example, you have Datadog and scaling. So I think I've covered a bit here. If so, by tomorrow we'll be doing or next we'll be going to the part three, which is some I'll cover some concept on load balancing, which is not much anymore. So it will just be three parts. All right, guys. My name is Moshid, and see you guys in the next video. Hope you find this insightful. And if yeah, them- the drawings are bad, but I think you guys understand what I'm trying to, the message I'm trying to pass. All right, guys, take care.